So I will show you how to make this in KiCAD. So this is a 40 pin FPC cable or flexible printed circuit, and this is, you can make it impedance control. I will show you that also. And you also can have this, the PI sheet that will be on top of it like this. I tore it off intentionally, and these are really strong, that they attach hold together. So you want this kind of FPC cable if you want to have a impedance control traces going from one board to another. So here is one of my PCB. So this have this IC that converts the HDMI signal to RGB for the TFT. So this HDMI signal needs to be impedance controlled. So I designed this FPC cable, that is a 40 pin FPC. So this is not same as this one. This is flexible printed circuit, and this is flexible or flat flex circuit. So these don't have any impedance control. This one have impedance control, this one have impedance control, and you just want to use this just to transfer non-impedance controlled traces. When it comes to designing this, it's not much different than designing a regular printed circuit board. So I will show you that how to do it in the KiCAD, and I also show you how to order them in a PCB house, that is PCBway. Today's sponsor is PCBway. They have PCB printing service starting from $5. You can order 10 PCBs in 9 different colors here. They also have 3D printing service, which is very reasonable. Go to the third section of the website and click 3D printing service and add your own STL file. Choose materials and other features and get a price. Check out their 3D printing service and PCB printing service from the video description below. So this is the FPC we will design today. Not exactly similar to this one, but I will show you how to do the connector, how to add a stiffener, and how to do impedance control traces, and add the ground plane that you can see, this hatched ground plane. So first we will design the connector. To do that, we will go to KiCAD and we will design the footprint. So here is the footprint editor. Then we will make a footprint in our library. By selecting the library, press this, then make a test PC. So set as a SMD. We don't need those. Now first we will add a pad. That pad should be similar to the connector that the FPC will go. So this is the connector where our FPC will go, and we want to see a similar FPC cable that goes to this connector. So this is the reference design I got it from Wirtten. Connector have 40 pins, and each pin is 0.3 millimeter width, and the pitch is 0.5, and the length is S1, so strip length, so that is 4 millimeter. So we'll design that according to the specs that we saw. So we'll add a SMD pad that goes here, then set the conductor length as 4 millimeter, then the width is 0.3, and make it as a rectangular. Now we will try to make an array of 40 of them. First set it to pin number 1. So by selecting the pad, then create from selection and create an array. So horizontal count is 1 and vertical count is 40. and vertical spacing, that is the same as the pitch that we saw here, 0.5. then same as the vertical offset, 0.5. then we click OK. Then we have this. Then we want to center them in the middle, so in between 20 and 21. So if you set your grid like this, 0.05, then you can center them exactly like this. Then we want to add an edge cut of this connector, so we will go to the edge cut layer, then set is a single layer mode. Then we will draw the front line or the front cut. We can set like this. Then we can set the length according to the datasheet. We can see this is the width W, then the width is 20.5. that is for 40 pins. So we will set same. To do that, we will divide in between these two. Then we have like 20.5. So if we see the distance from this to this, that is 20.5. Now this is our connector. Then we save this connector. Then we will add that connector. To do that, we will just add a generic connector. So we will set a connector generic. Then this 40 pin. Then we will assign our footprint that we created. This test FPC. Double press. Then this is here. Now we will go to the PCB editor. Then we pull our latest changes that we did in the schematics. Then we have our connector here. We need another connector on the other side, so we'll duplicate this, copy, Ctrl C and Ctrl V again. Then we have this. Then to connect each of the pins to other side, we'll rotate this and place it like this. Then we'll pull it apart. Then we have our connections like this. Then we go to our PCB editor. Then we again pull our latest changes. Then we have our other side connector. Then we rotate this. This is our FPC's connector in the both side. Now we want to connect the edge cut, so it will create a closed loop. So we will get our area of our PCB. So we will go to our edge cut layer. Then remember to toggle the single layer mode. Then we will add these two edge cut line together. Now this is a closed area. Now we want to view it in the 3D viewer. As you can see, this is a closed area of this FPC cable that we will make. Now we want to add the stiffener. So this is the stiffener, this blue part that I showed you in the beginning of the video. So we will specify the width and the length of this stiffener. So to do that, we will get a reference from this datasheet. So stiffener is D1. This is the length. So stiffener or support tape. This is D1. That is 8 mm. And the width is the same as the FPC cable. So that is 20.5. Now we will define our stiffener in our FPC cable. To do that, we need to define the size in the silkscreen layer. So as we defined our conductor in the first layer, we want to set the stiffener on the other layer. So other layer is B layer or the bottom silk screen. Then we will resize it according to our own need. So that is 8 mm is the stiffener length. So this is 8 mm. Then we want to fill the shape also. Then we'll copy this on the other side. We also want to add the dimensions. We'll go here, then like this we will add the dimension, so that's the 8 mm. Like this we will add the dimension, so that's the 8 mm, and this 20.5, same as this side. You also want to mention this is the stiffener. To do that, we will add a text. Now stiffener part is done. Now we will move on to the placing the traces. We'll just manually place the traces like this. So this is an optional part. I want to add these tracks as differential pair. To do that, we'll go to the schematics. Then there's two methods you can use to define differential pairs. One is adding plus on the label, so 3 plus, and minus on the other line. And another way is adding N and P. So either you can add P and N positive or negative in after the label, or add sign plus and minus. So if you go to the PCB, then pull the latest changes, then you can see this showing as a pair. Now you can go and select this and drag, then you will get a 2 option, or press 6, then you select this differential pair routing, then you press, then you have these lines as a differential pair. But for the differential pair, you can also need to control the impedance. So to do that, we will go to the board setup, then net classes. So we will declare a net class called diff. Then in this diff, we will add our differential gap and width that will create our impedance. You can calculate this width and gap of this differential pair using the KiCAD's calculator. So if you press this calculator tool, then it will give you this calculator. And we want to have a 100 ohm impedance controlled differential pair. So to calculate what's the width and the gap would be, so the width and the gap, the S. Then we need to set first of all these parameters. Then main parameter is this height. So in the impedance control, you need another layer on the bottom. So you need to see what's the height in between these two layers. To know what the H is, you need to go to your PCB fab manufacturer and see what the capabilities is. So I'm using PCBway, and see this FPC thickness. They can manufacture in multiple thickness, but we will go to the specification of this datasheet that we are trying to follow. Then we can see this conductor T or CD, that is the conductor thickness, so 0.05. So we will go here, then they have 0.05. So our PCB fab can do 0.05, so we will use 0.05 here. Then we will press this, then it will give us this. Then we need to see if our PCB fab can manufacture this with trace. So here is the minimum track spacing. It can do 0.06. So we need to increase this with more. So what we can do is increase the thickness. So if we increase the thickness by 2 times, then if we calculate that again, then we have this 0.08. I will use this width and this spacing. So I will define these 2 parameters in the differential width, that is 0.08, and the gap is 0.04. Then we press OK. Then we can assign that net class in these traces. So you select the trace, right click, then assign net class, then you set the net class to diff that we created. So you have to do it for each of them. Now we pull the changes, then route this line like this. So we have our impedance control traces, that is 100 ohm, and we need to have the other plane that is shown in the calculator. So that plane can be either a ground plane or a power plane. So we want to go here, then we will add the ground plane symbol. So this ground needs a reference, so I will get this reference from this pin by connecting it here. Then I will pull the changes, then again I will define the zone. Then draw the infill, then press B, and that will create this infill or field zone. Then you can see this zone here. Now this solid plane is not good for a flexible PCB, because when you try to flex it, it can get a crack after doing too many flexes. So we want to reduce that. Fracture by making it as a hatch pattern. So we will make a hatch pattern with the orientation of 45, then hatch width and the gap should be same. The minimum hatch width you can do is 0.25 millimeter, and same true for the gap. Then you press OK, then press B again. Now you can see this hatch pattern, and we also want to set this gap here, that is the gap in between the cut or the edge cut and the copper, by going to here, board and constraints, and set this copper to edge clearance. So that is now set to 0.1. We can set it to 0.05. Then we rebuild the pattern again, so it is much closer now. Now we will connect this pin 40 or here directly to the ground plane. So first we need to connect this 40 pin to the plane by simply doing this in the both side. Then we want to connect this top plane to the other plane using via. But you need to see what's the capability of the fab creating this via in this flexible PCBs. So we will go to PCBway. We will see what's the via size they can make. So the hole size is 0.15 and the diameter of the copper is 0.35. We can see the via specification from the board and net class. So this is the default, the via size and the hole. So we set the hole to 15, same as our fab capability, 15, and the size is 0.35. So 0.35. So we press OK. Now these vias are according to our fab manufacturing capability. So these vias now will connect this layer to other side. Now we will build it again. Then we have this vias passing our ground plane to other side. You can also add the dimension of the PCB itself or the flat plates. That we can do in another layer, in front layer. So this layer is defined in the front layer or front silk screen layer. Then the stiffener was declared in the bottom silk screen. So if we see the single layer mode, so this is the bottom layer where the stiffener are defined, and this is the size of the whole PCB. Now we will generate our fabrication output, so Gerber's. First we will set the folder where the Gerber's file will be. So I made this folder. Then set it as a relative path. Now we'll press plot. We'll refill it again. Then generate the drill file. Then generate the drill file. Then close. So now we will order our FPC in our PCB fab, PCBway. So we will go to their website homepage. Then we will go to PCB instant code. Then select FPC rigid flex. Then we will set all the parameters according to our own design. So the PCB type is flexible PCB. So design is only one, and layer, it has two layers, 1 and 2. So 2 layer. So we will set the size. So for us it's 27 and the width is 20.5. And the pieces, we want 5 of them. Then we will set the base material as it is, polyimide flex. Then FPC thickness, we calculated our impedance using 0.1 thickness. So this is the H. So we will set to 0.1. Even though in our design reference the thickness is this insulation thickness, so 0.43, I think the connector that we are using, it can handle little bit more thickness. So it doesn't matter for us if it is the twice as thick. Then we go to minimum track spacing and hole size and diameter for the vias. We already designed our via and the track spacing according to the fabricator's specification, so they are okay. Then the solder mask, we will go with yellow. The silk screen is white. The edge connector, we set it no. Then the stiffener. So the stiffener we designed that goes to in the bottom silk screen or the bottom layer. So we'll set it to bottom. Then the type of stiffener, we will use PI. Then the thickness of this PI, we will follow the specification or the design reference we use. So that is ST, or the support tape thickness, that is 0.22. So we will use close to 0.22 or this one 0.2. Keep others as it is or blank because we are only using PI. For the surface finish, if you change this, then also the price may vary. So I will just go with immersion gold and the thickness and everything as default. Then if you go to calculate, then it will show you the price. Then you press save to cart. Then it will ask for the Gerber file that you made. Then you upload the Gerber file. This. Then you submit order. Then it will create this. Then they will check your order. Then you will get a message. Then you can pay for your order. So this is the whole method to make a FPC cable according to your specification. As you can see, this is very simple to make, and you can make customized FPC cable that can be used for any simple to complicated PCBs. Thanks for watching.